All right, this is question 2 of the 2019 exam. So this was on their test last year. There were 4 parts to this question, but I am just having you focus on parts A and B because parts C and D are not parts that would be on your AP test this year. So let's go ahead and read it here. We've got a table of values. This is for particle P. Later on in the problem, there was another particle that was introduced. That's why this one's called particle P and not just a particle. It's moving along the x-axis. It's given by a differentiable function v sub p, where v sub p of t is measured in meters per hour and t is measured in hours. Selected values are shown in the table. Particle p is at the origin at time t equals 0. The origin is not like the point 0, 0. The origin, when you see it in these problems, is the position is equal to 0. So our position is 0 at time t equals 0. And this one says, justify why there must be at least one time t on the interval from 0.3 to 2.8. So I'm automatically going to be looking at this one here, 0.3 and 2.8. Between that interval at which the derivative of what I see here, which would be like the slope of what I see here, the acceleration, the slope of velocity of the acceleration, equals 0 meters per hour per hour. So we're just trying to say why this slope has to equal 0 at some point in that interval. So if we just think about plotting these 2 points real quick. At 0.3, we're at 55, and over at 2.8, we're also at 55. And the graph, it looks like it goes down to like -29 here. But what we know about this graph is it's a differentiable function. So if it's differentiable, that means it's continuous, and there's no corners in the graph. So the graph has, you know, some sort of a shape. Who knows exactly what it looks like? Well, let's just say it looks like that. And let's pretend none of these are vertical tangents because that would make it not differentiable, okay? So maybe my graph isn't perfect here, but you get the idea. So what it's saying is we have to say why there's a spot in this interval where the slope is going to equal the same thing as this slope here, and that is the mean value theorem. So Meg had asked a question on the stream, and I kind of gave a video to watch about the mean value theorem versus the intermediate value theorem. You might want to write those notes down and just have them handy, or like Google mean value theorem and write down what you find there, intermediate value theorem. Those are the 2 big theorems that you might see. The other one would be the extreme value theorem. That's the other one that sometimes shows up, which deals with maxes and mins. But here we're just going to make sure that we say it's the mean value theorem, and we're going to calculate what this slope is here. And we're going to try to get all of the points. So the first thing that has to be true with it being, in order to use the mean value theorem, you have to say because v sub p, so it's here, because or since v sub p of t is differentiable and therefore continuous. And then we're going from 0.3 to 2.8. And our slope, so I'm going to go from 2.8, so I'm taking my value at 2.8 minus my value of this function at 0.3, and then you divide by the x's, that's the change in y over change in x here, equals, so this would be 55 minus 55 over 2.5, which is going to equal 0. By the mean value theorem, we know So what we know is if there's a slope of 0 here, there's going to have to be a slope of 0 somewhere else in this interval, and they call it a value of c. Typically, this one just says verify or justify why there must be at least one time t. So there must be at least one t or c value. So we know there is a value and I'll use C because that's what our book uses, but you could probably just say there is a t value between 0.3 and 2.8 such that our derivative, which is what it's talking about here, is equal to 0. So such that, and I always make sure that I write it the way they have it. So v sub p prime of t equals 0. Okay, and there is, like that's kind of the way, if you look at the answer key, that's the way they worked through it. At the top it says or, and then they have another way to work through it, so you could definitely look through that. The other way uses the extreme value theorem, which is kind of neat, but definitely if you know one way or the other, you would be good there. You wouldn't have to do both. Okay, and then part B is talking about a trapezoidal sum, so it's a little bit easier. I feel like the mean value theorem people get really confused on sometimes, but I would be ready for that question because it's on the AP test often. Okay, so use a trapezoidal sum here with 3 subintervals. So we're going from here to here, from here to here, and then from here to here. So we're kind of ignoring that, it looks like. To approximate the value, we're going from 0 to 2.8. So for part B here, our trapezoidal sum, and we're approximating this integral. So I'm going to write this integral is approximately, okay, and if you need to plot these, you sure can. We've got our first point here at 0, 0, and then the next one is here at 0.355. We're going to draw a trapezoid in. If you know the area of a trapezoid, you average your bases, is how I think of it. Base 1 plus base 2 divided by 2, and then you times by the height. And our height for these trapezoids is actually what the width is here. So my height is going to be the 0.3. And I'm just going to write it out front. And then our bases would be, so I did this part here, I kind of mark up my table as I go, and our bases would be this 0 and this 55. So we've got 0 plus 55 over 2. Okay, and then we move to the next trapezoid, and we're going here from 0.355 to 1.7 negative 29. And don't get too caught up in it. If you think of like, oh, let's say it's here and here. If we draw this trapezoid, we've got the height would be how far it is from here to here. So that would be 1.4. And then in here, we're going to do our heights, which our heights are weird here. It's the 55 again, because we're using that same data point. And the next one is negative 29 over 2. Okay, and then our last one, we're going from here to here, which would be 1.1. And then, whoops, I forgot to cross this one off. Then we're going from negative 29 to 55 over 2. And then if you did that in your calculator or you just left it like that, circled that whole mess, that would be your answer. If I check the key here quick, let me make sure I've got everything right, everything looks good. And then it comes out to like 40.75 if you came up with the answer. This is just a one pointer, so having your answer using the trapezoidal sum, so showing some sort of work. So if you just circled this because it's a numeric answer, you would have full credit for part B.